Ladies and gentlemen, thank you very much. Once again, I would like to introduce one of my esteemed colleagues, Brendan van Wyk. He will be discussing a bit more of the tangible disinfection solutions that Xylem has got. All of you, please have a seat. You're welcome to listen to Brendan van Wyk. We will discuss ozone, UV, as well as AOP. If you don't know what it is, please listen. He will tell you all about it. Thank you, Brendan.
Afternoon, everybody. Not everybody's awake after lunch. I'm responsible for business development manager for Xylem with Eco, mainly for the pulp and paper industry in Asia, but I live in South Africa, so I was asked by the safety team to present on ozone and ozone water treatment options. Okay. Firstly, just a quick introduction as to who Wodeco is. Wodeco was founded in 1976 in Herford in Germany. They're still in the same offices. They are now the world's largest producer of ozone generators and UV systems, producing the biggest systems as well, the world's biggest ozone systems. Oops, I'll way around to get this thing up. Those are the offices, over 300 employees in the offices. All of our stuff are produced in these factories, both the UV and the ozone. All of the equipment is factory tested before leaving the facilities in Germany. Now let's introduce you to chemical close to my heart, ozone. What you can't do with ozone is not worth doing, really. Ozone is basically a triatomic form of oxygen. So it's oxygen with three oxygen molecules, atoms. It's a very sweet, pungent odor, very distinctive smell. Once you smell it, you'll never forget the smell of it. Detectable down to the parts per billion level. Pale blue color, but you'll never see that because you won't get close enough to those concentrations to be able to see the pale blue color. It's non-combustible, however, like oxygen, supports combustion. In other words, if you light a match in a room full of oxygen, the room doesn't explode, the match just burns a bit quicker. If you try the same thing with a room full of LPG, well, you didn't get the explosion. But the other main benefit of ozone is its very short half-life. So you're looking at about 20 minutes that ozone exists in air before it breaks down back to oxygen. The main benefit of that is then you don't have any residual chemicals left behind in your process. And most importantly, it is the most powerful, well, second most powerful oxidant really in use in water treatment usage. We'll touch on the hydroxyl radical and the AOP. So how do you produce this stuff? Ozone is produced through what is known as the corona discharge, which is basically a high-intensity electric current, which excites the oxygen molecules until the point where they break apart into oxygen radicals. Those radicals are really highly reactive, don't like being on their own, and grab onto anything else that's close to them, which in this case will be another oxygen molecule, to make the O3, as you can see there. You can only produce ozone in concentrations of up to about 13% on the commercial scale in an oxygen gas. Beyond that point, you start using a lot of power, and beyond about 15%, it starts becoming explosive. Under air conditions, you're only able to produce ozone up to about 3% ozone in the air stream. So on the larger systems, you can't really use air on the larger ozone systems just because of the volume of gas that you have to process to get the ozone concentration. So our ozone range, we have a full range from a few hundred grams of ozone an hour, all the way up through to our big PDO, which is purpose design systems, which we are now producing over 250 kilograms an hour of ozone in a single unit. So the world's largest ozone generators. That's what they look like. Effectively, it's a big shell and tube heat exchanger. We'll go into a bit more detail of the workings now. What makes Wodeco's system special is our electrode. We have a stainless steel electrode that's covered in a stainless steel mesh and then covered with a glass dielectric. These electrodes are the most robust on the market. They do not need replacing. We've got generators operating in the paper industry that have been operating for about 15 years, producing over 150 kilos an hour of ozone. The shell has never been opened, so those electrodes have never been replaced. Unlike our ceramic counterparts in the market, the ceramic electrodes tend to be consumables. And when you've got between 2 and 20,000 electrodes in one generator, you can see the problem with trying to change these out. So this is our big selling point. This is how it all fits together. The Ozone mesh is there for extended surface area. We have a grounding cap to separate the electrodes from the outer body. The glass dielectric is what actually creates the corona discharge. It separates the current, it stabilizes the current across the length of the electrode. The electrodes are about 1.5 meters in length, and about, you can see in the next slide, the diameter. They're quite small, a little bit thicker than my finger. They're also much smaller than the ceramic electrodes, which means we can get more electrodes into a single body, producing obviously more ozone, which is why we have the world's largest ozone production systems. So basically it's a big shell and tube heat exchanger. The electrodes all go into this side of the generator body. They feed into both sides of the generator body. The outer body is grounded, and you pass about 5,000 volts through each electrode. The whole shell is immersed in water, so you've got very, very good contacting between your cooling water and your electrodes, which is very important because a lot of the energy that's used in creating ozone creates a lot of heat, and heat is detrimental to the whole ozone generating process. So yeah, we have very good heat removal, so our power consumption is very efficient. As you can see, there's the placing of the electrodes into the outer shell. Tedious job. There's then a better graphic of how the whole process works. You can see the outer shell of the generator with all of the tubes inside. We place the tubes into the whole system. We hook it up to the high voltage current. Let's say about 5,000 volts onto the thing, close it up. Also unique on our system is the 2 power supply units, particularly on our bigger generators. We run at 2 PSUs. Each power supply unit is capable of producing up to 60% of the design capacity of the whole generator. Generators generally don't fail, while our systems do not fail. What tends to happen is you have electrical problems, and so the faults generally lie in the, oops, seems a bit touchy, let's see what, understand your problems there, it wasn't just you there. So generally the power supply problems cause most of the trips in these generators. So having redundancy on your power supply allows you to still carry on running up to 60% of your capacity of a single power supply while the other one is repaired. So you hook up the cooling water, hook up the feed gas, which is oxygen, generally on the bigger generator systems, turn on the power, and again our unique selling point on these systems is we can go from 0 to 100% design capacity in about 2 minutes of startup. Our electrodes do not need to be warmed up, they do not have shock problems. We can have a trip and restart the system within 2 minutes without any problems or failures on the system. So what do these things look like? This is the largest system that we've sold so far at Fabria Jacarai in Brazil, producing 150 kilos an hour out of the single unit. You've got the 2 generator bodies at the bottom and the power supply units on top, so in a single shipping container. So very, very small footprint, purely plug and play technology. All you need on this is a plinth for the system, plug in the oxygen, plug in the cooling water, the power, and in 2 minutes you've got full ozone production. Our system is called the Z Compact. It's fully self-containerized. All our systems are completely test run to full capacity at our facility in Germany prior to leaving the factory. Customers can come and view and actually see the test run of the system to sign off on it. The beauty is you have no housing requirement. It comes in its own little box, so you don't have to put it in any other buildings. It's a very small footprint, as I say, the size of an isothermer. purely plug and play, and then modular in design. So if you need to expand, you just put down another container with another generator in, and you've got full production. And then, operating in harsh conditions is probably the important point in this condition. These systems can run in temperatures of, we've got one running in Asia, about minus 45 design temperature, and we've got them running over 35 degrees C ambient temperatures. I mean, the container is fully air conditioned and sealed, so outside conditions don't bother it. As you say, our single system is producing up to 10 tons a day of ozone. Mostly importantly on all of these systems is availability. Ozone systems in the past had quite a bad name for going down and causing problems. Our systems with the new stainless steel electrodes, in the last 2 contracts we signed at the end of this year, signed over 99% availability into the contract with penalty clauses if we do not meet that. We are so confident about our systems that in the paper industry, the penalty clause we've signed is that for every ton of pulp not bleached by the ozone, we will pay for it. So that's the one in Brazil. But it's because of the fact that we don't have to do the maintenance of taking apart the electrodes and cleaning out the shell all the time. So what does this wonderful gas actually cost? Producing ozone is about power and oxygen. Okay. Generally, about 10 kilowatts of power per kilogram of ozone produced. However, if that oxygen is coming off oxygen generation system, you need about 8 kilograms of oxygen to produce 1 kilogram of ozone. As I've said, you can't produce up to about 13% ozone in oxygen. That 8 kilograms of oxygen, if you were generating it in an oxygen generation plant, a VSA, consumes about 0.28 kilowatts per kilogram of oxygen. So in total, the total cost of production is about 2.24 kilowatts per kilogram of ozone. It's a good way of costing it. So if you know your power cost, you can pretty much figure out what your operating cost will be for the ozone system. So if you take into account capital, amortization, maintenance, oxygen, all the rest of it, you're looking at between 15 and 25 rands per kilogram of ozone produced on site. That's all in costing. Okay. But each project is designed uniquely. We look at each customer's requirements and format the size of generator, concentration of ozone, all that kind of stuff for each customer. So now you've got a cheap, reliable source of ozone. What can you do with this gas? The list of uses for ozone is growing every day. I think it's a chemical that's finally come of age. People have understood the green technology that you can use using ozone. Most importantly to this audience is the drinking water and wastewater systems. However, the biggest consumer currently in the world is in the paper industry, bleaching of pulp. Groundwater remediation in terms of water reuse is another growing technology. And then the industrial processes. Cooling tower water treatment. In order to treat the cooling tower, you generally need about 5 different chemicals. You need your biocides, you need your anti-scalants, you need your corrosion inhibitors, you need your pH control. You can do away with all of these systems just running an ozone generator. This allows you to then stop your discharge of effluent out of the cooling tower and cycle up the water to a lot higher concentrations than you can with chemical treatment. So you save money on chemicals, you save money on effluent treatment, and the ozone treated cooling tower generally operates a bit more efficiently than your chemically treated systems, so you can save money on power. The other one that is becoming more and more apparent is the pharma waste, pharmaceutical, breaking down of pharmaceutical elements in our water sources, where we'll touch a bit more on that on the advanced oxidation process. Okay, so for the benefit of this audience, I suppose drinking water was the main focus. Why would you use ozone in a drinking water plant? The benefits of using ozone are the improved flocculation that you get with the ozone gas as a result of the bringing down of other elements like iron and manganese. Using ozone precipitates iron and manganese on contact and actually improves the overall flockability of the water. You actually see ozonated treated water has a sparkle to it. You can actually see the clarity of the water. Color removal, very effective at reducing TOC's color. Taste and odor control. Algae removal, as I said, TOC oxidation. And then this is one that's just starting to take effect here, but in the States is quite a big deal. It's removal of your emerging contaminants, things like endocrine disruptors and those type of chemicals in your incoming water system. Generally, those type of chemicals, the pharmaceutical effluent that ends up in our water supply, tends to go straight through a general treatment process. You need an oxidation step to break it down. This is where ozone comes into its own. And then, of course, primary disinfection. How does ozone work? Ozone for disinfection is very effective because unlike chlorine, which has to actually go into the cell before it disrupts and kills the cell or the organism, ozone actually oxidizes the cell membrane and ruptures the cell. You can build up this zero tolerance to ozone. It's deadly on pretty much everything we know: spore, bacteria, viruses. So completely destructive in everything. It also operates about 3,000 times faster than chlorine, so your contacting time and size of equipment is smaller. So where would you put this then in a typical drinking water treatment process? Generally, you have pre-ozonation for precipitation of metals, primary disinfection, or after flocculation, you can have an intermediate ozone step for taste odor control. And then after the whole process, you can end up with the post-ozonation step as your primary disinfectant. Okay, but because of its short half-life, so you're talking about your chlorine residuals, you cannot do away with chlorine. However, you add far less chlorine into the system. And because ozone has done all the work and destroyed all of the organic material, you don't produce any of your AOXs, your halogenated organics or chlorinated organic compounds, which have been proved to be carcinogenic and cause more secondary problems. So now you'll have chlorine acting purely as a secondary disinfectant, so long-term disinfection in the whole process water. The other technology in Wedeco's arsenal of disinfection then is UV. Okay, I'm still not convinced on UV, but my colleagues will convert me slowly, I suppose. UV is using the energy of light to create a chemical reaction within a cell. You're actually breaking down the DNA of the cell with UV light sitting at the 250 nanometer level. UV light is the light spectrum just above visible from 400 nanometers down to about 100 nanometers of light range. The one we're interested in is the UVC band at the 254, which is the highest absorption rate of DNA within the cell. So you end up with a high absorption rate at that point. Wedeco's lamps probably have the highest efficiency in terms of producing light at those levels. What the light does is actually disrupts the internal structure of the DNA of the cell membrane. So you end up disrupting the whole functioning of the cell. You stop the cell from actually reproducing, and ultimately the cell dies from the disruption of the DNA. There's no residuals, there's no chemicals that you need to handle. Very easy to install. It's basically you'll see the pictures coming on now. You don't change the chemistry of the water. Because Unlike both chlorine and ozone, which tend to rupture cells and just release all of that material into the water, the chemistry of UV takes place within the cell. So the cell stays intact. So it dies as a membrane. You can filter it out then effectively. But you don't release that material into the water. So you have no effect on taste or odor, and you have no effect on the actual chemistry of the water. No corrosion, obviously, because you're not adding a chemical into the system. But like ozone, you have no regrowth of the virus and bacteria or parasites because of the disruption of the internal systems. No hazardous chemicals on site, and no resistance. Chemical-based disinfectants tend to build, bacteria bugs tend to build up a resistance to those chemicals, and you need to change your chemical process every 3 months. UV and ozone both, there is no resistance that can be built up to the chemical. So you can continue using it as is without having to try and change your process to try and prevent the bacteria building up resistance to your process. So, UV generation, this is how it looks. It's a series of lamps. They look like your fluorescent tubes. Wodeco uses low pressure lamps, which means basically have very little bit of mercury ball sitting on the one side of it, and they then pass an energy current through the lamp, excite the mercury, and you get the mercury vapor, which gives you the UV light. Same as the fluorescent system. Our system has the highest intensity of UVC, the 254 nanometer range, 3 or 4 times higher than the conventional processes, which means we have higher operating efficiencies. So the current that we use to generate the light is effectively used as the energy. You're not producing wasted energy into the process. We have very good stability in terms of fluctuating water temperatures, and a very long lamp life, about 12,000 hours. The UV applications, this is also growing as people are becoming more aware of the abilities of UV. Pretty much targeting the same range of uses as ozone, where you're not looking for a secondary disinfectant or a secondary chemical in your process. A growing use is in your ultra pure water supplies, into like the pharmaceutical industry, where you don't want to change the chemistry of the water, so this is where UV then becomes effective. Drinking water disinfection is growing. It's very popular in Europe, the use of UV for drinking water. And then also secondary disinfection of wastewater, so your disinfection of the discharged wastewater out of the water treatment plant. Food and beverage is growing for like your CIP type processes. And then any process where you need to have disinfection without oxidation. Like in the sugar industry, so disinfection of a sugar stream where you can't oxidize the sugar. You can use things, something like UV. And then headspace disinfection. They've got these separated, but yeah, those kind of two go together, ships and trains and headspaces. So your water treatment, your water tanks, storage tanks on the ships and trains, you put a UV light across the surface of it and disinfect that whole space. Our range, we have a full range of UV equipment going from your small home use processes up to like 13 cubes an hour, right through to your big K range, which is your big drinking water facility plants. They're all these bigger ones are more purpose-built, but full components, you can put them very simply into a process. You can see it's basically a pipe in, pipe out, very easy to install, and very effective. On the other side of it, we have the wastewater side. Those are the drinking water disinfection processes. And then on the other side, we've got the wastewater system. So this is your processes for disinfecting of your final wastewater effluent. Same thing, we've got the anglized systems with their wipers on them. You can see there. We're going to go into that a bit later. And then we've got specialized products for the pharmaceutical industry, these EM processes for clean water in the pharmaceutical industry, and then the headspace disinfection systems. It's all very well having a very good UV system, but if the UV light doesn't get into the water, you're not going to get the disinfection. Our systems come with purely mechanical wiping processes. It's a wiping sleeve which moves across the lamp on pre-regulated, or we have sensors that can pick up the changing in the intensity and wipe the system automatically. Being completely mechanical, there's no additional chemicals that can add an impurity into your process. We also use pneumatic drives on the wipers, so there's no hydraulic oil potential spillage. And increases the life of the lamps, and also it can be done without interrupting the process. So the lamps are clean while the process is operating. It doesn't have any effect on the overall disinfection capacity of the process. These two technologies don't have to stand alone. UV and ozone, if you combine them along with hydrogen peroxide, you end up with a system called AOP, Advanced Oxidation Processes. This is a growing technology as the waters of, global waters, drinking waters and incoming waters deteriorate. There's a requirement for more and more advanced oxidation processes to remove contaminants from the water sources. What is advanced oxidation? Advanced oxidation is taking advantage of the hydroxyl radical, which we spoke about a bit earlier. That is the most aggressive oxidant that we can use in a water treatment environment. It reacts with just about anything. Also very, very short half-life. And is generated through the combination of UV and ozone, UV and peroxide, or peroxide and ozone, or a combination of all three, depending on the requirements of the process. But the idea is to come up with a system where the goal is to maximize the OH radical production at the lowest possible cost. Because obviously this is all adding cost to your processing system. Basically what you're doing is taking a highly toxic compound or just hormone like the endocrine disruptors and breaking them down into more biologically biodegradable products, or just into less harmful products in themselves. Hydroxyl radical, as you can see here, with an oxidation potential of about 2.8, sitting above ozone on a 2.08. You can see chlorine and chlorine dioxide are way down the list, down the bottom here. The type of things that you need for advanced oxidation. These are the chemicals that have been becoming more and more spoken about, more and more discussed, and people realizing that these are actually causing health problems in people. You've got your dioxins, which are carcinogenic. You've got your endocrine disruptors, which are your hormones and all that kind of stuff. All of these contaminants generally pass straight through both the water treatment and drinking water and wastewater treatment processes. So they're accumulating in all of our surface waters and all of the waters around the world. The only way we can get rid of them is through oxidation. So this is where we start now looking at AOP. In fact, in the States, they've already regulated a lot of these. They are starting to be regulated here as well. So let me introduce then our range of advanced oxidation technologies. We have processes, Wodeco being the most advanced ozone and UV system suppliers, are a unique opportunity to combine the two and come up with the most advanced AOP systems on the market. We have systems combining both ozone and peroxide, ozone and UV and peroxide, or all three are micro systems. The ozone peroxide generally good for majority of your contaminants. However, depending on the requirements of the plant, you may need a multiple barrier process where you can combine all three. The UV system is NDMA. I can't remember. NDMA, I'm blank on the. It's a hormone. It's a Yeah, it's one of the underground disruptor type chemicals. I can't remember the breakup name. That is where the UV system was designed unique specifically to target that chemical. So we have a basic quick list of how and where these processes can be used. Surface and drinking water treatment for taste and odor, and micropollutants, as I said before. Groundwater remediation. This is actually happening a lot in the States. It should be happening here, where they're refilling aquifers, like under Las Vegas. They've drawn that aquifer practically dry, so they're now taking surface waters, treating it and pumping it back underground, using advanced oxidation processes to do this. So ensuring that that water is really, really clean. And then, in terms of the reuse processes, tertiary treatment of wastewater to a point where you can actually bring it back as potable water. Windhoek, for example, is using ozone to treat their wastewater, and they're pumping it back into their drinking water system to a maximum 30% of the old waste water is now drinking water. So this is just some pictures of our processes, how they look. These systems come fully installed, they're plug and play processes. You can put them into the process without minimal disruption to your whole operation. This is the UV and peroxide process. You can see you have a peroxide pumping station, injection point, that then goes through a UV chamber to create the hydroxyl radical, and then into your process. Because the chemistry is so short and so quick, you don't actually need much residence time for the process to take place. The other one is the peroxide and ozone. So you have your peroxide and ozone injection point. Goes through a series of static mixers to ensure that you have complete mixing. A degassing point, which will then remove the oxygen, basically, that's coming off from the ozone, the excess oxygen, and back into your process. And then the last one which we're introducing is ProMix. This system is specifically designed for high bromate water content. Bromate, not a huge issue in South Africa, but in the drinking water in the States, they have bromate. Bromate on exposure to ozone creates bromic acid and a whole lot of other precursors which are not ideal. So we've come up with the process of minimizing the formation of bromate using ozone, using the ProMix system. Okay, so Xylem, we're uniquely positioned to assist in all of your process waters through our knowledge of ozone, UV, and advanced oxidation. And we've got a global team of experts that can assist you in solving all of your water problems. Thank you very much for your time. Thank you.
Do you use medium pressure UV lamps at all?
We do have one range of medium pressure, yeah.
So it gives you a wider wavelength range of genocidal range with medium pressure.
Yeah. What's that? I'm not the. Speak to that man. He can answer you on the UV side. That's. I'm UV.
I still mainly low pressure.
Yeah, most of our lamps are low pressure, but are very specific to the wavelength requirement. 254 nanometers. They're very tuned into that.